Hi everyone, welcome to our first video. So this is for lesson 1.1. So when you watch the videos, you just need to make sure that you pause it when I ask you to and you do the work so that way you can practice it. And also that you write down any questions you have. So keep a sheet of paper next to you so that way if you don't understand something I'm doing, you can write it down. Or you could just even like circle something so you know to come back to it or ask when we go over things in class. Okay? So, like I said, write down any questions you have to make sure you understand all of the stuff we're going to go over. So in this first lesson, we're going to talk about functions. So hopefully this is a review of things that we've learned in our past algebra classes, Algebra 1 and Algebra 2. Okay, so let's start with all these giant list of definitions. So our first definition is a relation. And so the formal Precalc definition is that it's a correspondence between two sets. So really, back in Algebra 1, you would have learned it's just a group of ordered pairs. So it's just a group of numbers that relate to each other. So to make that a function, then that means that every x can only have one unique y, or it's not a function. Okay, so there's the formal Precalc definition, but the basic part of it is that every x is only paired with one y. The y's could repeat, but like you could have the 0.2020, but then it's not unique, or it's the same thing, so it would be unique. But if we had 21, well, we're going to go over in a second. So that's really what you need to focus on, is that every x only has one unique y. So the x's can't repeat again, okay? Okay, so our next thing is domain and range, which we've talked about these, a lot in algebra. So domain is your input values, or it's the domain that is able to be used for that specific function. So some functions, any number can be plugged in. Other functions, you're going to get something that's not real, or that's an imaginary number. So that would not be put in with our thing because it says for real numbers. Okay. And some numbers, if we plug them into our equations, we'd get undefined if we end up with a 0 in the denominator. So that has to do with our domain too. Okay, so think of domain as what x numbers are we allowed to have for that specific equation. And so the range is the output, so the numbers that we would get out by using those x values. Okay, so where is our range of y numbers that we're going to have? A map is just, you might not remember these from Algebra 1, but it's just a way to show you the inputs and outputs of our x's and y's and how they relate to each other. So it's kind of like a table, but it has like arrows connecting things. So the independent and dependent, our independent is always our x, and our dependent is always y. So the domain is the input, is the independent variable, whereas the range is the dependent and it's the output. Okay. Implicit and explicit, I don't know if you learned those terms before, those might be new, but an implicit function is when it has all of the variables kind of on one side, or it's not explicit. And explicit means that it's y equals or f of x equals. So you solved for the dependent variable. Okay, so this is when, like, if we had x plus y equals 5, that's implicit. But if we have y equals negative x plus 5, that would be explicit. And our last thing is function notation. So that's when we use the f of x. And f of x like represents y. So instead of saying y, we just say f of x to show that it's a function. Okay, so let's take a look inside and look at the examples that we have to go over. So our first set is just determining, are these functions? So remember, our rule is that the x's all have to be unique. Okay, so if we take a look here, our x values, we have a 2, a 4, 3, 4, and 5. So all those x values are different, so yes, this would be a function. And I'm not going to write out why, but it would be because all the x values are unique. Okay, so this, for question 2, you're going to go finish that one on your own in a second. For question 2, this is a mapping diagram. This one has to do with the calories versus the grams of fat in these food items. Okay, so if think about this one for a second. Would this be able to not be a function? That would mean that they would have like two arrows coming from the same thing because it wouldn't be paired with a unique value. And if you think about the application of this, each sandwich can only have one amount of fat grams, so it would have to be a function because you can't have two lines coming from the same sandwich. One sandwich doesn't have multiple grams or different fat values. Okay, so this would be a yes. Okay, so for those questions that are left, I want you to try to figure out if it's a function or not, and then when you come back from unpausing your video, I will tell you if you are correct or not. Okay, so pause your video and do those other questions that are in that group. Okay, so this one was a no because we repeated that -1. Okay, very good. 3A was a yes, all our x's were different. 3B was a no because we have repeaters that have different y values. This would have said 9. It would have made it, I mean, that wouldn't have made it not a function, but it went to different things for both of those sets. And number 4, that would be a yes. You remember the vertical line test? That helps us to see if it hits more than one point. Okay, but as we can see, none of our x values repeat. They're only hitting that line once. Okay, so that's why it's a function. So let's move down. So for these, it says to convert each implicit equation to the explicit. Remember, this means y equals, so we want to get the y by itself, and then we'll determine if it's a function. Okay, so let's do this one together. So if we want to get the y by itself, we move over the x squared. So y equals 1 minus x squared, or you could put -x squared plus 1. And then to get rid of the squared, we take a square root of both sides. So y equals 1 minus x squared. Do you remember what we're missing? Very good. You have to put the plus or minus. When you're solving equations with square roots, it has to have plus or minus. And if you don't remember why that's true, then circle your number 5 so you can ask me in class and I'll explain why that's true or why that happens. Okay? So is this a function? Well, if you remembered what the graphs look like from Algebra 2 or Algebra 1, then you might be able to tell without thinking about it algebraically. We don't have the graph in front of us, and that's not until lesson 1.4, I think. So we'll just talk about what happens with the math. So I'm going to pick an x number. Okay, so if I say x is 0, what do I get out? Well, I get 1 minus 0, which is 1. So I get the square root of 1, which is 1, so plus or minus 1. So that means then y equals plus or minus 1 because of this. So y is both positive 1 and negative 1. So that means I'd have 0.01 and 0, negative 1. Is that a function? Nope, it's not, because it happens, or our x values don't have unique y's. There's two different ones. Okay, so that's why it's not a function. Okay, and you can pick other numbers in there and plug them in and see what happens. Okay, so if you remember the graph, I want to show you the graph now because I like showing you stuff. So if you remember the graph of a square root, if we graphed y equals the square root of x, it would be like that. So if we put the negative, it'd be like that. So this ends up looking like a sideways parabola when you have the plus or minus, and it doesn't pass the vertical line test. Okay, but algebraically, plugging in and kind of looking at like that would probably be the best way to go for you. Okay, so I want you to try question 6. Pause it, see what you get when you solve for y, and then we'll talk about if it's a function or not. Okay, so if we solve for y, we get this with those crazy fractions. So I said yes, it's a function because this is just y equals mx plus b, a straight line. Linear equations are always functions. Awesome job. So let's take a look at question 7 up on the top. So for these questions, it says, what's the domain? So remember, domain is what x values are we allowed to use in our equation. Okay, so what are we allowed to use? So take a look at number 7. What kind of equation is that? Very good, it's quadratic, which means the graph looks like a parabola. Okay, So if you remember some stuff from Algebra 1 or 2, we should know what that graph looks like. So a regular parabola would look like this. What are we allowed to plug in there for x? Good. We're allowed to plug anything we want. It ends up going, any big number will work, any small number, any numbers in the middle. Okay, so all real numbers work for parabolas. So another way to write that would be like negative infinity to infinity. Okay. So since it's just x squared, anything's going to work. Do you think that's going to be true about questions 8 and 9? I hope you said no. Since this is a fraction, we're not allowed to have certain numbers in the denominator, like 0, or just, so we need to figure out what's going to make that happen, and that's not allowed. So that would not be an allowed x value and not in our domain. Are we allowed to have any number inside a square root? We can't end up with negatives inside there, so that breaks the rules too. And so those would be numbers that we're not allowed to have in our domain. Okay, so let's look at number 8. So to figure out what we're not allowed to have, we're going to have to figure out what makes the bottom equal 0. So if we solve this equation, set it equal to 0, and see what we get, then we'll be able to tell, okay, well, this is what causes our zeros, so that's not allowed in our domain. So we got that x equals plus or minus 2 when we take the square root. So that means if I put a 2 or a negative 2 in there, I'm going to get out a 0, which is that's not allowed. If you divide by 0, the whole universe explodes. So we can't do that. Okay, so that means our domain is everything except negative and positive 2. Sorry, my timer's going off. It's almost time for class to start. Okay, so that means that we can't have positive or negative 2. So, I mean, that's not the way we're supposed to write it, but that's what it means. So it helps to write it out like that. So I'm going to show you 2 different ways to write it. One of them is using like the interval notation, which is usually the way that I like it. But I'm going to also show you the fancy way that you'll see in like calculus and stuff. Okay, so if we write it with this, we know we're allowed to have everything smaller than negative 2, but we can't be negative 2, so we use the parentheses. And then I could have numbers between negative 2 and 2, but not 2. And then I can have everything bigger than 2. So since we're just excluding those 2 numbers, it ends up meaning we're going to have three parentheses, because then everything's smaller, in the middle, and bigger. Okay? Another way to write it, and I'm not sure if you've seen this way before, is using these brackets. Then we say x such that x is whatever we want. Okay, so I'm saying that x cannot be equal to plus or minus 2. So this reads again, our domain is x such that x is not equal to positive or negative 2. And I know that way is a little weird, but usually like the upper level math classes, that's how they do it. I like the interval kind because I think it's more self-explanatory. Okay, so let's take a look at 9. So remember, I can't have numbers that are less than 0. Okay, so I want this to end up being bigger than 0. Well, it could be equal to 0. But we can't have negative, so that's why it's like that. Okay, so if we solve our equation, we end up with 4 is greater than or equal to 3t. So 4/3 has to be greater than or equal to t. And if we flip that around, then we get t has to be less than or equal to 4/3. So our t's would be everything that's smaller or equal to 4/3. Okay, so if we wrote that in interval, we'd have everything smaller than 4/3. And then we make a bracket to make it equal to. If we want to do it this way, we would say x such that t, or it's jk. We're using t's, sorry. I like x's. I always use x for everything. So t such that t is less than or equal to 4/3. So which way do you like doing it better? Like I said, I like that way better. Okay, so the next part is just plugging in things and using that function notation. So for like 10, you just plug in -3 into your x's and see what you get. Same thing for 11. Plug in -x in your x's and see what you get. Okay? This one, it's saying our function is negative, so where would you plug that one? For 13, we're plugging in x plus 3 into our x's, and then we're multiplying everything all out. Okay? So, why don't you pause your video and try 10 through 13, and then after that, I'll go over this one with you because it's a little bit more work. Okay, so pause and do 10 through 13, please. Okay, everyone, we're back. So, for number 10, I got 33. 11, I plugged in my -x, simplified those negative signs, and got 2x squared plus 5x. For this one, our function is negative, so my function is this, so I made my function negative. So I just distributed that negative sign. So for 13, we plugged in x plus 3 into each of our x's that we had. So I had 2 parentheses x plus 3 squared minus 5 parentheses x plus 3. So I FOILed to get rid of the squared. Here I distributed the 2, and then combined like terms. So we ended up with 2x squared plus 7x plus 3. So remember, if any of those, if I went too fast and you got confused, just circle, star, do something so you know to ask about it when we go over it in class, okay? Okay, so let's look at 14. So this is the same idea, and if you think you can handle it, go ahead and pause and try it. I'm going to work through it, and then you can fast forward and check your answer. So I'm plugging in x plus h into my equation, then I'm subtracting my function, which is this, and I'm dividing the whole thing by h. So I'm going to have, for the first part, 2 times x plus h squared minus 5 times x plus h. So that took care of that. Now I'm going to minus my function, and this is my function. So minus 2x squared minus 5x. And then I took care of that. And then in the bottom I just have one lonely little h. So I know we don't have much room here, so when I do the next steps, I'm going to not write the fraction until the very end, which is a bad habit to get into, but I'm doing it anyways because I write big. Okay, so just our top. FOIL first, distribute. So 2x squared plus 2xh, plus h squared. If you have a question about that FOIL, then write your 2 parentheses and do it. And if you still have a question after that, then ask me in class. Be careful with your negative signs. Like here, those are both end up negative. Here we distribute, so we ended up with a positive. And I know it's all over h, I'm just not going to write that. So now I'm going to distribute again. So 2x squared plus 4xh plus 2h squared minus 5x minus 5h minus 2x squared plus 5x all over h. So now we can combine like terms. So 2x squared minus 2x squared, those cancel. What else do we have? Minus 5x plus 5x. And that's all of our like terms. So we end up with 4xh plus 2h squared minus 5h all over h. So every single term we have there has an h, so that means we can simplify. So if I have this over this, those h's cancel out, so I'd have 4x. 2h squared over h would just be 2h. And then minus 5h over h would just be minus 5. So that would be our final answer for that one. So if you got confused, make sure you star it, and or circle, and we'll talk about it in class. I can't believe how long this video is. I'm sorry. I don't mean to make them this long. There's just a lot of math in this lesson. So hopefully your other videos usually won't be this long, okay? So let's take a look at the back. So this is just doing stuff that you should be pretty familiar with. So here we have these 2 functions, and now we're going to add them, subtract them, multiply, divide. Okay? So for 15, we would have f of x, which is, or f plus g. So f is x plus 2, 1 over x plus 2, plus g. And then we would just need to simplify it from there. So just think about regular fractions. How would you add those fractions? Well, they have different denominators, so we'd have to get the same denominator. So that means I would take this fraction and times it by this denominator, and then this fraction times by that denominator. So that would be x minus 1. I'm going to write it. I mean, the bottom is going to end up being x plus 2 times x minus 1 because we're timesing each fraction by the opposite. So that was how we got our common denominators. If I'm skipping too many steps, make sure you ask about that one in class. Okay, so I'm going to times this fraction by that denominator. So it would end up being this, because this times this. Okay, and then we can simplify and solve. So distribute, combine like terms. 16 is just like 15. 17 we're timesing, so we'd have 1 over x plus 2 times x over x minus 1. So remember, when you multiply fractions, you multiply straight across. So that would be x over x plus 2 times x minus 1. And there's nothing to like cross out here, so that would be it for 17. 18, we're dividing, so f divided by g. Oops, that's an x. So you remember what we do when we divide fractions? Flip and multiply. So the top stays the same. Then we change it to multiply, and we flip the bottom one. So we have x minus 1 over x. So now it's like this, like multiplication, so just go straight across. So x minus 1 over x times x plus 2. And that one's it. And that one's done. So I want you to do those two and pause, and I will show you the answers, and then that's it. Okay, so when we simplify the top, this is what I got. Okay, there was nothing to factor. If you can factor, you got to keep going and factor, but you couldn't factor there. On this one, it was a little bit different since we were subtracting, so make sure we like distributed that negative sign. Sometimes I get lazy and don't write in my parentheses. So that would be it. Okay, so if you have questions on either of those, please make sure you circle, star, or something and ask me about it in class. Okay, that's it. Werner out.